Hello, everybody. Are you ready to begin Chapter 2? This is our chapter on the research methods of social psychology. If you've had Introduction to Sociology or Introduction to Psychology, you've had quite a bit of this material before, so it should make it an easier chapter. But that being said, of course it has new material. I think it would be boring otherwise. So let's begin. Before we begin the concept of thought experiment, I just wanted to say that on most PowerPoints, I don't show my image again to save you download time and to use less memory. And on some slides, you'll see no teacher commentary at all. For those slides, I really thought that the slide spoke for itself, and I'm not going to narrate just for the sake of narration. I thought you'd appreciate that. Now let's consider the concept of a thought experiment. I would suspect you haven't had this before, at least an introduction to psychology. In a thought experiment, you speculate about how you would most effectively test a hypothesis. There are many, many, many ways of testing a hypothesis, but which would be the most straightforward, the most logical, the easiest to test, the most ethical? So you run through all these possibilities in your head and make your selection, and this uses quite a bit of critical thinking, though it might be parallel to before you get out of bed each morning, you might try to go through what you need to do that day. So it's similar, but much more scientific. And let's consider our next slide. So at this point, we've reviewed the scientific method. We've learned how to construct a good hypothesis. We've talked about ethical issues of use of people and animals in psychology research. Next, it's time to actually look at the most used research methods in psychology. How do psychologists obtain their knowledge? Magazines, internet, secondhand sources. Hopefully you're not tempted by those answers. See if you can decide where we do get our knowledge, and then we'll see on the next slide. We utilize the scientific method. You are likely to have come across a scientific method sometime in your past. We're going to divide it into 4 distinct steps. Your previous teacher might have had a pre-step. If you had a pre-step, that's fine. You can certainly keep it. So let's take a look at these steps of the scientific method. So for our first step, we have develop a hypothesis. The asterisk means I'm going to have some cautions for you in the next slide based on common mistakes I see students make on tests. You cannot put the word hypothesis. It's a lazy answer. It's not a complete concept. So develop a hypothesis is a good answer, though you do not have to say develop a hypothesis for me. You could say, well, think of some different ways of saying develop a hypothesis, and I'll pause for a moment. Create a hypothesis, good. State a hypothesis, excellent. Formulate a hypothesis. You get the idea. So on the test, definitely tell me a phrase involving a hypothesis. You also need to know this hypothesis needs to be a statement, not a question. You'll see that on the next slide. And also, it must be specific. It's not sufficient to say that one variable affects another. How does it affect it? It makes it quicker, slower, bigger, smaller, and so on. So again, it needs to be a specific prediction. For step 2, you could put test hypothesis. That's a logical follow-up. Conversely, it's also very good to put gather data. Either one is good, but don't put both on a test. If you double list a step, it makes me think that you're confused. So choose one or the other, whichever you prefer. I've listed for you some of the different ways of testing the hypothesis: observational research, case study, survey, correlational study, experiment. So we have many options, including these, and some additional ones as well. The next step, you'll create a mountain of data. The next step would be analyze the data. Do you have to use the word analyze? No, you could interpret it. You can apply statistics to it, but you get the idea. More than just one word. Last step, and a lot of students stop there, and unfortunately they can't get full credit. The last step is to publish the results. Can you share that differently? Absolutely. Share the results is also very good. So absolutely positively make sure that you can easily list the 4 steps of the scientific method. So in the previous slide, I mentioned these cautions. Again, one-word answers will be marked wrong if it's discussing the scientific method. A hypothesis must be a statement, not a question. It must be specific. I often have students that say that one thing affects the other, and unfortunately they don't receive credit. You have to be specific. But here's a question for you. For step 2, we said you do not have to put gather data or test hypothesis. What if a student puts do an experiment? Do you think they'll receive credit or not? Unfortunately, this student would be marked wrong, and very commonly on tests, 25%, 30% of the class would get marked wrong on this particular step. Why is this not correct? It says do an experiment, which means you must do an experiment. But what if the person wants to do a correlational study, a survey method, and so on? So your answer must include all the possibilities. If you say gather data, that includes all the possibilities. If you say test your hypothesis, that includes all the possibilities. So your answer must be inclusive. So do an experiment only limits you to an experiment. So you would not receive a credit. So again, caution on your test. So let's apply what we learned on the previous slide, or perhaps it was review. That's fine too. So for each of these statements in blue, decide if it's a good, solid hypothesis or not. Please actually do it. It'll help you prepare for the test. The first sentence is a question mark, so we know that it is not a hypothesis. It must be a statement. The next one, the middle one, it is a statement and it is a highly specific prediction, which is very testable. It's a good hypothesis. And by the way, it actually is true also, but that's beside the point. The third one, although it's a statement, it's too vague. It is not a true hypothesis. Will it increase the quality? Will it decrease it? Too vague. So the only one that flies is the middle one. How did you do? Now that I've snuck in that little public service announcement, let's return to our task of the scientific method. Look at these three students, student A, student B, student C. Look at each answer and see if you think that would be acceptable or not for a test. Let's look at student A first. Step 1, great. Step 2, big problem, too specific. It leaves out many research methods. 3, fair enough. 4, also good. For student B, number 1, much too lazy. What about the hypothesis? That would not receive credit. 2, fine. 3, fine. 4, also fine. Student C, 1 is good. 2 is vague enough. It's also good. 3 is good. And 4 is good. So make sure that you, if asked this question on a test, would be able to do it easily. So let us begin the very important topic of sampling. Since the population is usually way too large to be in our study, we take a subset, in other words, a sample, and we generalize to the population. Some students confuse the term population and they believe it means all people. No, it's the specific group you want to learn about. For example, maybe one researcher looks at people with Alzheimer's that develop it prior to age 65. Thank goodness, very rare. Maybe another researcher's population are girls with ADD. Maybe another population might be transgender people of color, and so on. So it's not everybody everywhere. It's the specific group you wish to learn about. Often that would be tens of thousands, hundreds of thousands, or quite possibly millions of people. Obviously, you don't have enough days in your life, space on your computer, people working for you to tackle such a population. So again, we sell for hopefully a very good sample. Now, when we go about this, we have two major choices. Do we want to do random or convenient sampling? We'll consider them a little bit later in the slide, but first we have to tackle the concept of representative sample. And bias sample, hopefully you've already covered these well in Intro Psych, so this is likely to be review. But if not, no worries. So before we go on, if you could try to fill in the blanks that you see for representative sample, bias sample, and at this point, since I've introduced the concept of population, try to do the blanks on the bottom right. Actually, go ahead and do it. So for a representative sample, it's a subset of the population, which is structured exactly like the population. Or maybe you want for a slightly longer version, a subset of the entire group of interest, which is structured exactly like the group of interest. The bias sample is the opposite. It's a subset of the population, or if you prefer, the entire group of interest, which is not, see the not is bold, which is not structured like the population or the group of interest, whatever you put in the first blank. Researchers never set out to create a biased sample. Think of the bias as the bad type. In Introduction to Psychology, I talk about a famous poll done quite a long time ago, and they were trying to figure out who was going to win a presidential election, just like they're doing at this very moment between Biden and Trump. But back in this original sample that I'm talking about, they had a very large sample, very good size, geographically very diverse, and they were asking who was going to win the election, Alf Landon or Roosevelt. At this point, I would often ask my students to raise their hand if they're familiar with President Landon. And of course, no one raises their hands. Furthermore, the pollsters thought that this Alf Landon fellow was going to win by a landslide. Well, he actually lost by a landslide. FDR won it easily. So there's something about their sampling procedure that was very off and created by a sample. I asked students to guess. Again, it wasn't the size, the geographical mix. And then I often give them a hint, 1930s, what was going on? The Great Depression. So how they did the sample is they called people randomly by phone, but very, very, very few people had the phone, just the uber rich. Or they sent postcards based on car registrations. So not only did you have to have a car, it had to be legally registered. Again, you'd be above average in terms of the amount of money you had by far. So in a time that most of us would have been very, very poor, they managed to contact only the very, very rich who were voting for Alf Landon. So because their sampling procedure accidentally created a biased sample, their predictions of the survey was total garbage, but it did get them famous. So to hopefully create our needed representative sample, we have two choices to make. We can either do random or convenience. In random, every person in the population, in other words, the group of interest, has an equal chance of being studied. Ideal, but that's kind of hard to do, so many times we settle on convenience sampling. So for example, all SCCC college students, or you'll often see children of the university, other university employees being used, or students in Introduction to Psychology, for example. So convenience sampling can produce a very nice representative sample. But again, our basic choices are random versus convenience. And now we are done with this little small but hugely important topic. Let's now turn our attention to the survey methods. It's a collection of methods which includes questionnaires, polls, interviews. It's particularly useful if our goal is to learn about opinions and beliefs. Survey methods are used quite a bit, though not necessarily in psychology, but in many disciplines. Even though they're used quite frequently, there are many problems associated with the survey methods. Let's, for example, say that I'm a sex researcher. I do teach human sexuality typically every year. So let's say I choose to do a survey method and to learn about a particular subject topic. What sort of problems might I come across in using the survey methods to learn about some aspect of human sexuality? Think for a moment and see if you can come up with some of the problems of this method. Let's now turn our attention to the survey methods. It's a collection of methods which includes questionnaires, polls, interviews. It's particularly useful if our goal is to learn about opinions and beliefs. Survey methods are used quite a bit, though not necessarily in psychology, but in many disciplines. Even though they're used quite frequently, there are many problems associated with the survey methods. Let's, for example, say that I'm a sex researcher. I do teach human sexuality typically every year. So let's say I choose to do a survey method and to learn about a particular subject topic. What sort of problems might I come across in using the survey methods to learn about some aspect of human sexuality? Think for a moment and see if you can come up with some of the problems of this method. Did you say dishonesty, lying, stretching the truth? That is a significant issue. Also, poor sampling. Perhaps the researcher had some sort of biased sampling issue. Or perhaps a researcher is lacking skills. Maybe their interview skills are poor, or maybe their item construction on their survey is poor. Next, you call poor memory, or I'd also accept human memory. The longer the past, the less accurate the memory would be. And also poor data return, and poor data return would lead to, of course, issues in sampling. So they are definitely tied into each other. So if these problems are avoided, survey methods can provide good data, but the researcher has to avoid all these issues and more to get useful data. Let's now consider a study called the correlational study. Its purpose, prediction. When we want to be able to predict one variable from another. There are three types of correlations that might come out if we did correlation research: a positive correlation, a negative correlation, or a zero correlation. So let's consider these three types of correlations. For a positive correlation, let's say that we will predict, remember correlations are all about prediction, we predict there's one variable increasing. What do you think the other one will do? It will also increase typically. And it gives us on the end, so as one variable increases, the other usually increases, and if one decreases, the other usually decreases too. So as one goes up, the other tends to go up. As one goes down, the other tends to go down. For a negative correlation, we will predict, remember correlations are all about prediction, we will predict that as one variable goes up, what do you think about the other? Yes, it typically goes down, and vice versa. So as one goes up, one goes down. Here's a question for you as we consider the zero correlation. What about prediction for a zero correlation? Consider that for a moment. So again, as we've learned, positive and negative have nothing to do with good or bad. It has to do with our data. So in the first example, if we graph the data and saw this pattern, that would indicate there's a positive correlation between those two variables. As one goes up, the other gets up, and if one's a smaller in one, it will tend to be smaller on the other. B is a negative correlation. So if one variable is high, the other one tends to be very low, or if you're looking at a very low one, its corresponding data point would be very high. So you can see the pattern of data points for a negative correlation. For the third example, they chose height and GPA. No predictable relationship. Knowing one does not help you predict the other one whatsoever with any degree of accuracy. And you'd see a pattern that's just random, and thus you could not draw that line of best fit, which you can easily do with a positive or negative correlation. Let's do a couple more examples, because I assume that you're still learning the concepts, and that's fine.